AI agents keep making the same mistakes.
Not because they're dumb, because they literally cannot remember what happened 2 conversations ago.
Every session, they start fresh. Every session, the same failure.
A developer decided that was unacceptable, and the fix they built is borrowed directly from your brain. Hippo is an open-source memory system for AI agents, inspired by the hippocampus, the part of your brain responsible for forming, storing, and selectively forgetting memories. And that last part, the forgetting, is actually the most important piece.
Here's what it actually does.
When your agent runs with Hippo, every interaction gets stored as a memory node.
But not all memories are equal.
Hippo assigns each memory a relevance score that decays over time, exactly like biological memory. Something that happened last session matters more than something from 3 weeks ago, unless it was reinforced, accessed again, proved relevant again. The system uses a graph structure to link related memories together, so when your agent needs context, it doesn't just pull the most recent thing. It pulls the most relevant cluster. In practice, this means an agent running Hippo can tell you it already tried a particular API endpoint and it failed, without you having to remind it.
It can notice that a certain type of user query always leads to a dead end and route around it.
It can build a working model of a project over time instead of rereading documentation on every cold start.
The demo in the repo shows an agent managing a multi-step coding task across multiple sessions, and the difference is striking. Without Hippo, it re-asks clarifying questions it already got answers to. With Hippo, it picks up almost exactly where it left off.
But here's the thing, Hippo is not magic, and the limitations matter.
First, memory retrieval adds latency.
Every time the agent needs context, Hippo runs a similarity search across the memory graph.
On a small project, that's fine.
On a high-frequency production agent handling hundreds of concurrent users, that overhead compounds fast. The library doesn't yet have built-in support for distributed memory stores, so you're essentially limited by whatever single machine or database you can attach to it. Second, the forgetting curve is tunable but not intelligent. You set the decay parameters, and if you set them wrong, your agent forgets important things or holds onto irrelevant ones.
There's no automatic calibration based on outcomes. If a memory was wrong, it doesn't penalize itself.
You have to build that feedback loop yourself.
Third, and this is the one that will bite most people, Hippo doesn't solve the context window problem. Your agent still has a finite context window.
Hippo helps it choose what to load into that window more intelligently, but if the most relevant memory is also very long, you can still run out of space.
It's a prioritization layer, not a compression solution.
What surprised me was how clean the integration is despite those constraints. You're looking at a decorator pattern, wrap your agent's memory calls, define your storage backend, set your decay parameters. If you're already deploying agents on DigitalOcean with a Postgres or Redis backend, plugging Hippo in is genuinely close to plug and play.
That's rarer than it should be in this space. Now, where could this realistically go? The most compelling near-term application is multi-agent systems.
Right now, when multiple agents collaborate on a task, they each maintain separate, disconnected memory. Hippo's graph structure is actually well suited to shared memory pools. Imagine 2 agents working on the same codebase, both reading and writing to the same memory graph, with conflict resolution built into the decay model. That's not in the library yet, but the architecture supports it.
The other realistic path is feedback-weighted memory.
If you log whether an agent's action succeeded or failed, you could feed that back into the relevance score. Memories that led to success get reinforced, memories that led to failure decay faster. That's closer to how reinforcement learning works, and it would make the forgetting actually intelligent instead of just time-based.
So why does Hippo exist?
Because the standard solution to agent memory, just stuff everything into a vector database and retrieve by cosine similarity, doesn't model importance or recency in any meaningful way.
Every memory is equally flat.
An agent that made a catastrophic error 2 years ago weights that error the same as something it learned this morning.
That's not how useful memory works. The developer behind Hippo looked at decades of neuroscience research on how the hippocampus actually handles memory consolidation and asked, what if we just implemented that? It's not a complete solution.
It's a layer, an opinionated, biologically grounded layer that sits between your agent and its memory store and makes retrieval smarter.
For solo developers building long-running agents, it's worth adding today.
For production systems, it needs work on the scaling side before you'd want to trust it. Next episode, we're looking at a tool that takes the opposite approach. Instead of remembering more, it aggressively compresses context to keep agents fast at scale.
If Hippo is the hippocampus, this one is more like amnesia with a plan.
Subscribe so you don't miss it.